Hi everyone. My name is Fawaz Ghali. I'm the developer advocate at Hazelcast. I'm excited to be here simply to, speak and talk about Hazelcast, but at the same time, I would like you basically to tell me about what you're currently working on, and it will be great to reach out and see what we can do for our community. We're trying to reach out and do these talks, so what I'm planning to do today is just to carry on do continuation, and obviously we have some answers to some of these questions raised today. There is a keyword from my presentation here that I would like you to focus on. So essentially I will try to explain what real-time stream processing is and how you can basically use it in your working environment. But I would like you to focus on this keyword here. Because after all, it doesn't matter when it comes to performance if it is like too much complex solution you want to have. So you want to focus basically on simplicity when you implement solutions. Before I start my talk, I would like you to scan this code. So I was told that we're not allowed to do this as a raffle. So this is a chance for you basically, if you scan this code to win £100 voucher or $100 voucher, just to make it sure that it fits with this theme for this talk. So if you can tweet us or take it to the social media and give us your opinion or use any hashtag, we will pick it up. So, but you need basically to scan this QR code in order to be included in the raffle. So a bit background about myself. I want this talk to be an interaction talk, so I don't want to be technical heavy. I want to make sure that you live today and you know exactly what Hazelcast can do for you, and perhaps you give it a try maybe this week, see what kind of possibilities you can achieve with Hazelcast. So that's me. I'm Fawaz Ghali. I'm based in Liverpool. That's where I came from. And the theme for my talk today is to focus on football. So I think, is football popular here? Yes? No? Okay. So that's good. So the idea is just to show you what you can do with Hazelcast. Obviously, the same context can also be applied to any environment or any use case. But generally speaking, because I'm based in Liverpool and we have a Liverpool football club, so that's what I will focus on, but I will show you how you can switch the context. So football is quite popular in Liverpool, and we have a problem in this season, basically. On the screen here, you see actually two problems. So you see first problem, which is like we're sitting in 7th place, which is not ideal as we start. But if you think about it, why it's happening, you probably need to have some kind of analytics going on to understand what's going on here. So the actual problem, and this is how Hazelcast came into place, fits in this area here, as I will show you. So what we were trying to do now for this talk is just to analyze data in real time and show you what you can do as well, in your working environment. But before we, go to the demo, I think it's important to, be on the same page what we mean by real time. So real time means, various things for various people. For the context of Hazelcast and this talk, essentially we're talking about milliseconds. So this is where, we're trying to provide solutions in real time, and real time in this case means like milliseconds. That's what we're looking for. So we're not looking for, actions or events happened yesterday or last week or last year. We're interested in what's going on now. And the way to measure it essentially is kind of provide some kind of measurements. So for us, kind of like milliseconds, that's where we kind of like work with So these are just examples here. So what you can, typically have in real time. So for example, camera flash illuminates in 1 millisecond. So this is pretty fast. The camera shutter speed takes 4 milliseconds, and usually human eye blinks in 1/3 of a second. Now, if you think about it in context of sports or football or Formula One, these things like shift slightly, obviously, but we're still talking about, parts of milliseconds. So for example, do you know the answer for fastest goal ever in football? Or for example, how long it takes for a wheel spin in Formula One? So these kind of numbers, like for example, wheel spin might take like 100 milliseconds, which is like 1/10 of a second. So that's pretty quick, and it can determine who's going to win and who is not going to win. So that's what real time is. But speaking about real time without context isn't ideal, because what you want is kind of like getting the benefits of both. So what you see on the screen here is kind of like description between what is batch, or what we can describe it is data at rest, data stored somewhere. And it used to work up to this time, like around this time, like 2022. And these things changed now dramatically. So for example, these are just examples where you can see use cases for real time, where, for example, now if someone is banking, so that's where things like happening right now. Or for example, when you go online to do some shopping, so you get some kind of recommendations, that's also happening right now. Or watching Netflix on all these stream platforms also, and also in fraud applications. So for example, if I'm here in Poland and my card is being used in Liverpool, my credit card is being used in Liverpool, I want to know, and I want to know now. I don't want to know about it like 1 hour late. Also for medical use cases, so where we have critical situation where it requires to provide some kind of answers happening in the current state or in the current moment. So real time by itself doesn't give you full picture. So you always need to have some kind of data or slow data. This slow data refers to the context. So you want to get data in real time, which is what's happening now as a content, but also you want to have some kind of a context for your use case. And the solutions are usually a combination between these two. So between fast data coming now and the slow data which is stored somewhere. So this is where you need to start to think about solutions. So what type of tools you can use, and what type of sacrifice you also have to apply for your solution. So if you want to, for example, to compare real time versus waiting time or latency for your applications, and you see that we have an x-axis here just to measure this. So if you have your data coming in real time, that's probably fast and quick. But if you start to think about processing your data, you probably need to add another layer to your application. So for example, some solutions provide this end user analytics, so such as Confluent or Databricks, but the sacrifice here is the latency as well as complexity. And if you also want to store it in some kind of fast storage, so you probably also need to add latency or waiting time to your application. So what we're saying today is, even if you can manage to do it this way, you probably need to look for solutions which provide some kind of simplicity in development as well as deployment. So if you think about it, if, for example, I want to buy a new bed, for example, from IKEA, and I have two options, one option with the user guide of 10 pages, how to build the bed, and another user guide with 100 pages on how to build the bed. Basically, I want, obviously you're going to choose this solution as well with like minimal effort to apply it. And that's where Hazelcast come into place. So Hazelcast can provide a one-stop for all your needs. So you can have stream processing capabilities within the platform. You can have fast access to data using cache. And you can also apply some kind of machine learning inference or predictions, as we will do today. Also, you can do some kind of data preparation or end user analytics. So, for example, the demo today is going to be exactly in these steps here. And all I needed to do, and that's what I love using Hazelcast, and that's why I think I chose to work for Hazelcast, is simplicity when it comes to providing solutions. So instead of having 10 jars to do 10 jobs, and every time you have to upgrade and do configuration for various jars, various tools, platforms, essentially you can just have one Java or one jar file. You can have it in embedded mode, which gives you like very low latency, and you're good to go. You don't have to, do anything apart from the configuration. But it's also important to how we compare to other tools and platforms. So I think some of you mentioned some tools here. So, and Gregor also had this slide on his talk, but I wanted you to think about it. So I wanted you to think about this slide in terms of how you can deploy it and how you can develop your application. So if it happens and you want to work in two different areas, you're probably going to use basically two tools or two platforms. So I think you mentioned Cassandra previously in your question. So my question to you is, what do you do for stream processing? What tool or platform you
well, currently Flink.
Flink. Okay, so
but it's not in that project.
Yeah.
I'm not using Cassandra. We use RocksDB as a backend for the Flink state.
So, have you done any benchmark or any kind of performance?
Well, in the scope of that solution, that's a contract. And the technology are not in the discussion. It's not the agile client. We can change the technology and say, oh, we find something better. So I made the performance test, and Flink is it's resource consuming, but it's powerful, and but I don't have a comparison with the other tools.
Yeah, so I have one slide about benchmark, so I will show it. But for this slide specifically, I want you to think about it, the easiness when it comes to work with various technologies. So instead of integrating two tools just to do like online or real-time stream processing, what we're saying is Hazelcast can provide this solution in one platform. So the platform itself provides you with stream processing capabilities as well as in-memory storage and pretty much caching features. And this is where the both components or both sits in one platform, so one jar. So think about it like how you want to achieve it from your side. So I'm not sure about Flink, what it provides, but what I can say about Hazelcast is the platform is very flexible, and this is important to understand because after all, you don't want to add extra layers to your application, because adding extra layers not only not cost effective time-wise, but also add some kind of latency to your application. So platform is quite strong in terms of handling sources as well as things. So where you take your data, where you want your data to go to. And if for whatever reason that we don't have this source or we don't have this thing, for specific use case, we can always do custom connectors. So you can build your own connector basically, and it's you can publish it on our open source platform. So everything we're talking about open source, obviously, but for the demo, what I want to show you is the capabilities of doing these two and how many lines of code. So this is another thing I wanted to ask, like for example, a specific solution, if you want to compare two platforms, and one platform provides you with like maybe 20 lines of code and our platform requires maybe 200. So which platform would you choose? And simplicity about writing code in Hazelcast is amazing, because the problem I'm trying today to find solution for didn't take me long to deploy, to create the code, but at the same time it's quite robust. And specifically for stream processing, because traditional stream processing has some issues, so mainly for latency and complexity, and this is where Hazelcast can come into place. So for traditional stream processing, usually you have some kind of streaming sources. This is where kind of like get your data from Kafka or IoT or messaging queue. And once you have jobs deployed within your stream processing, you need some kind of ecosystem. So whether it's like, for example, Spark, for example, or other tools that are related to kind of like handling this type of stream and provide some kind of processing to it. But what happens if you want to access data at rest, or you want to have some context? So think about it as maybe any online recommendation system. So you get recommendation for your actions happening right now, but also the recommender system will look at your history, right? So what kind of events, purchase, or streams, or movies, or whatever recommender system is working on. So if you have this stored in some kind of external data sources, so this will add a latency or complexity layer to your application. So for example, NoSQL or using data grids is pretty fast, but you still need to access data from hard disk. So you have some kind of maybe network hooks or input output, or even if it is like quite robust in the RDBMS, you kind of like having the RDBMS is slow anyway. So this system complexity, that's where the main benefits of using Hazelcast. So it provides answer for latency, so it becomes faster in terms of accessing data, and also for the complexity when it comes to provide the solution, not only for the development, but also for the deployment as well. Because if you think about it as well, how we can scale our applications in Hazelcast, we don't have master worker type of relation. We have kind of like a pool where every time you add a new node to your application, or you define a new node, to your cluster, every node will know that's we have a new same thing. If for whatever reason one node fails, every other node will be notified. And this happens like in terms of it's easier to deploy when it comes if you want to scale your application. Whereas traditional deployment, so kind of like if you work in that area, you know how hard. So basically you need to duplicate every node, especially for the master node. So if your master node fails, you need to have some kind of backup. Same thing for the worker node. So to give you some kind of thing, some kind of context, what you can think about is it's good, I think, to compare between these solutions. So it depends obviously on the use case you're working on. So some might suggest using databases, which is good for some cases. But it's a storage only, so no, for example, no distributed compute on your database. Obviously, it's heavyweight, so it's not ideal for edge applications, and no stream processing capabilities. While data grids are quite fast, obviously, but they also don't have cloud support, or even they don't have stream processing. And if you look at stream processing engines, so these are just too slow to handle batch jobs or data at rest or data stores, but also heavyweight, and they don't have some kind of real-time analytics. So this is also, if you want to add it to your application, you probably need to look for some kind of platform library to do it. Whereas in-memory computing platform advantages kind of like provide best of both. So we have some kind of in-memory grade, so the caching feature as well as the distributed compute. So if you want to scale your application and do the stream processing, and you can have it either in like client server mode or as embedded mode. So it depends on the situation or the context of your application. And as Jacob mentioned, so we are cloud native, so that's easier. Also, if you want to deploy it on the cloud or even use our own Viridian platform, and it's extremely fast. So this is important, but also I want to define what is fast, because I think it's important to not only think about how easy it is, but also what kind of advantages you get. So the advantages here is kind of like we have partitioning not only on the compute, not only on the processing, but also on the data. So this is the caching. So this will give you maximizing parallelism for your application. And we also have data-aware processing, which means basically you have data locality. So this will reduce latency on your application and also simplifies scalability. So whenever you want, it's easy to add a new node to your cluster or remove nodes. And we also have in-memory optimization just to make the application faster. And also the SQL capabilities, whether it's over Kafka or file. So I will be using this today to show you how you can also do it as well. And the extreme performance. So obviously, this is like a buzzword. What does it mean? So we've done this study before where we managed to run 1 billion transactions per second with 99 percentile under 30 milliseconds latency over 45 nodes. What is interesting about this is the linear scaling. So this is very important to understand. This is where Spark and Flink comes into place. So this study is available online. We have latency here. I think it becomes easy. So the lower is better because it is faster. And the blue one is where Hazelcast is, or the JET component of the Hazelcast platform is. So whether it's like maybe 100 milliseconds to 1500, so that's like 15 times more slower for example, in the case of Flink. So that should give you some idea on performance for Hazelcast. And the study is also available online on the Hazelcast website, so you can try it out. So that's in terms of performance. But the other capabilities you can have within the platform itself is the real-time streaming analytics. So this is what I want to show you today. So in order to understand what's going on why you need to use it, obviously it depends on the situation. So obviously recommendation or recommender systems, everywhere on your mobile, on your tablet. It's related to maybe even like our talk today with our recommended talks and so on. So you get some kind of personalization. So this is why I want to highlight the problem for predicting who will score next for Liverpool, and also what type of real-time offers or even payments. So we have some kind of relationship with banks and finance institutions, so to provide this kind of real-time capabilities. So essentially, in your case, what you need is just to define your data source. Whatever application you have, you need to have some kind of source that connects your data into Hazelcast. And obviously, you need to have some kind of messaging bus, which is usually Apache Kafka. And that's where you can integrate Hazelcast. And obviously, Hazelcast will give you the extra feature which Kafka by itself doesn't give you, which is like storing and caching data in memory. So this will allow you to access your data at rest in much faster way if you compare it just to data store. So if you remove this, if you remove the Hazelcast component from here, you can still connect your data stores to Kafka, but what you will lose is the processing time to access the the records from here. Now, when it comes to deployment, you have two options, and there is no right or wrong answer here. So it depends on the context of your solution. What you want to make sure is to focus on: are you interested in how simple your application is, or if you want very low latency or in-memory storage as well as stream processing capabilities, so you can deploy it locally, which means you just add a jar to your Java application. Obviously, you need to connect your sink and sources, or you could opt in for using the remote deployment. So this is, for example, a completely different deployment situation where you focus not only on the low latency, so maybe you sacrifice this in terms of accessing data at rest. Obviously, there are some best practices that you can use that I would like to highlight. And essentially, what you want to make sure if you're processing a data in real time is you want to make sure, first of all, to ingest the data in real time. So as it comes, you want to make sure that you have data. So you don't store it first and then process it. You process it as soon as you get it. And obviously, this is connected to using, for example, the fourth point here. So you don't need to process the data which comes in real time multiple times. That's where the platform, or in our case, Hazelcast, comes into place. You process it once, as I will show you today, and basically the platform will handle it for you. And if you're not Java developer, so the SQL is good choice for you. So you can do the real-time analytics without knowing Java, simply by using SQL. And this is integrated with Hazelcast, so you don't even need to add any other libraries or jar files. And also, you want to make sure to minimize disk input-output, because this will add time to your application, so it will add latency. And you focus on simplifying your code, which is very important, regardless if you're using Hazelcast or not. And you also need to think about if you want to sacrifice the downtime or not. So it depends on the situation. So testing applications in a normal business hours doesn't give you the best or optimal solution. You want to test it in peak times to make sure that it doesn't break. And if it breaks, that's also a feature that you can use in Hazelcast, which provide zero downtime, and also to avoid the enemies. So I highlighted this because it's important. Sometimes it's easy, or sometimes it's manageable to do, other times it's not. So if we look at enemies here, so in some cases, for example, network hooks, that you can't do anything about it. What you can do is minimizing the storage input-output. So that's where the caching features come into place. Also, you want to make sure that context switching between processors, because this will add some time. You want to make sure to avoid it. And also excessive or unnecessary elements to your architecture. So same example I mentioned about IKEA's bed. So whether it's a user guide with 10 pages or a user guide with 100 pages, definitely we will opt in for 10 pages because it's easier. And same thing here. If you have an application you want to process your data in real time, you don't want to integrate libraries and platforms from everywhere, a platform to do stream processing and another platform to do fast data access or caching mechanism. You want to make sure that you simplify your code also if you want to do data enrichment, you want to make sure that also this will be added to your data retrieval. So I've done the major part of talking, so I would like now to switch to my demo. This will give you some context where you can use Hazelcast. If you have a situation in your work placement and you're not sure how you can use Hazelcast, I'm staying after this talk. So feel free to stop by. I think I mentioned we have a full house from Hazelcast here, who are really experts. So we have our CSO here. We have my boss as well. So we have very expert people here. We have Thomas as well. So I think it's useful if you stick around if you want to know how you can use Hazelcast in your working or for your use case. What I'm trying to do today is just give you an idea. And my idea is kind of like give you what you can do in real time. So I picked up this demo because I think we had a few weeks where we started the Premier League in the United Kingdom. We have also Champions League. I think there is a match going on today as well. Liverpool didn't start well for some reasons. And I have a friend who works for LFC, for the football club, in the data analytics part. And they do some kind of, real-time data analytics to see, because, replacing players is not a human decision. So yeah, obviously it's related to manager. In our case, it's Jurgen Klopp. But obviously there is some kind of input from his team. If you notice, there's some people with tablets just to give him some stats in real time. This is important. Why? Because it's not only related to player who is playing or related to the player who is sitting and want to be replaced, but it's also related to the context. So what they have is this number. So let's just forget how they calculate it because nobody knows. Obviously, this is like an arbitrary number, so secret number, for example. But this is my input here. So I have a match here, and this match, in my case, it changes minute by minute. Obviously, because we have 1, 2, 3, 4, 5, 6, 7, 8. I have 8 players here. So I have data entry for 8 players in 1 minute. But if I will show you after this slide, if I put the whole file in front of you, you will see this will change. So every minute, all players will get score. So we're not interested now how this score is calculated because we're not looking for this. But if we want to understand why Liverpool is not playing well, so someone suggested essentially we have competitions internally, which means, players and boys are not passing football simply because they want to score. So there are other factors related why they want to do it this way. So in order to understand or decide who is going to be or who is going to play, we need to have some kind of mechanism to convert these numbers. So again, we're not interested how this is being calculated. We're interested who will score next. So this is very important because if you remember from slide, I put it on player of Liverpool team. I think media mentioned this, so I'm not telling anything secret or anything like this. It's just because we have too many good players, and this is a problem because every one of these players want to score. So we want to make sure that if we want to analyze, we want to predict who will score next. So forget about Hazelcast for now. So in order to do what I'm planning to do, what you see here is the same file, but with same players, but instead this is the output. So the algorithm will tell me basically who will score next. So it's kind of a prediction here. Obviously, it's not the purpose of this talk to discuss how this prediction works, or whether we can change the algorithm or apply different algorithm. I'll explain my solution, obviously, but we were interested in doing this with Hazelcast. So if you want to do it without Hazelcast, you can do it, but you will sacrifice time, and time in real time is a problem, because if you remember from the first slide I put, so fastest football goal was 2.35 seconds, which means they look for not only seconds but also parts of seconds. So this is crucial. So if you want to process it in real time, you can use, for example, stream processing capabilities in real time. But what if you want to look at players' profile or history from previous games, and you want to integrate it to create this score? So this is not possible, and that's where Hazelcast can come into place. So in Hazelcast, my solution to handle this issue is to provide two maps. In my case, I'm using something called linear regression. So in simple terms, I would like to create trend based on this data here. And based on this trend, I would like to see which player will score. So I'm using a trend. I'm storing it into memory, which means I don't have to access data stores or physical files anymore. Everything I need is loaded into memory. And my stream processing capabilities, which is the prediction part, also part of my application. So everything I need is in one environment. And what is nice about it is the implementation. So I will show you the implementation, how easy it is to implement. But just let me put the workflow here so you can understand what I'm talking about. So this is the same slide as before, but we're looking at actual components. So I'm reading from source. So this could be Kafka, could be a file, could be a combination between Kafka and files. It doesn't matter. Even if you have a file format which is not covered by Hazelcast, you can write source for it. I'm adding timestamp to know exactly and at which moment I want to create the trend and the prediction. I'm calculating trend. So there are various ways to do it. One feature in Hazelcast is called windowing. So if you have, for example, a list of events, you can have a window based on these events. For example, if a football match is 90 minutes, you can have a window size of 15 minutes. Based on this 15 minutes, you can do your prediction, and then you do your trend, and then you move it. Depends if you want to move it 1 minute, you can do so, and you move. So the trend will change based on the window size and the time frame you're picking, and this will be stored and then grouped by player and stored in this trend map. So as soon as it's stored, you don't need to access anything else. So everything will happen automatically for you. We will use the trend map here to create a prediction. So the trend map will look for the trend. So basically, how players are doing within this trend in this algorithm. It uses the linear regression. So it looks for a X and Y. So we have players on one side, on one axis, and we have the actual score prediction on the other side, and we have just a line for the prediction, and this map will store results. Now, it's your job to decide how you want to present it, obviously, how you want to visualize it or analyze it. So we have results stored here in map, and you can output it in various formats. So you can output it to file if you want to. You can use it for other predictions. You can send it to a Kafka stream. So from, for example, Premier Leagues to Champions League, it can happen on the fly. If you have application, which is like the most used case, where you want just to look at results, you want to know who will score next, so that replace player, or even you can use the SQL browser. So this is another option. So I will stop here. I'll come back to my slides, but let's just go through the demo here. And I need to exit here. Okay, so everything I mentioned just took less than 200 lines of code. So this should tell you how easy it is to use Hazelcast. And what I like about it is simplicity in writing. So first of all, forgive my Java skills. So maybe you write better Java code than myself. But the way to do it is to define a POM file. In your POM file, you just need to say, I would like to get Hazelcast, for example. And that's pretty much everything you need will be integrated. In my case, because I'm using SQL, I'm integrating this part of it. And of course, I'm doing something else with it. So you don't need to worry about this. In your solution, what you just need is just to add one jar file to your project. So if you're using Maven, for example, you can simply say, I want to add this dependency, and that's pretty much it. Now, if we go back to my code here, so it's 3 lines of code here. What I'm saying is I want to define pipeline, and this pipeline is reading from CSV file. It doesn't have to be CSV. It could be Kafka, for example, or message queue. It could be any source. Even if this source, we don't have connector for it, you can write for it. Then we define instance of Hazelcast, and we run the jet engine. So pretty much 3 lines just to get the platform up and running. If you want to scale your application, you can simply add a new instance by adding just calling this method here, and this will add a new instance or new node to your cluster. Now for the actual pipeline, so as you remember, I mentioned 2 libraries, I mentioned 2 maps. So first map is just to do the trend. You can, first part is to read from the source file. And in my case, I'm just analyzing or parsing the data. So the timestamp here, the score, as well as a player. And then based on here, I'm defining my trend, grouping by player, which is entity in my case. If you want to define window, you can do so here, but it depends on how, what is duration you want. So for example, in case of football, if you want to define a window of 10 minutes, 15 minutes to calculate a trend, you can do it here. And then for the linear regression, it's simply going through the trend and picking each player at every minute. It doesn't have to be every minute, it could be any time frame you use, and you can do the prediction here. In my case, I'm saying if my prediction is bigger than 100, this player is going to score. That's what the algorithm is predicted. And in here, I'm writing my results into map. So this is where the other map comes into place. You don't have to write it to map. I'm just writing it to show your results. But you can, for example, send it to JSON if you want to. Or you can write it to web app if you want to. And as you see, it's just 1 line of code, which should give you a rough idea what is Hazelcast capable of doing. And then just some DAO classes to do this. Now, if you want to run the application, essentially what you need to do is to call. So this application is running, but I will show you what you need to do. You just run the application by running this 1 line of code, and this will generate a Hazelcast instance. And this Hazelcast has an IP or address for it, as well as port where it's running. And nice thing about Hazelcast as well is we have also management center. So think about it as admin page to see what's going on. And if I open this one here, I think Jacob mentioned this one here. So this is the management center here. And you can see your cluster, how many nodes exist, so how many members in your cluster. You can look at how many maps. Also, you can look various performance on your application. But what I'm interested in showing you the prediction here. So this is the SQL browser. Essentially, you can write SQL to access results if you don't want, or if you don't know Java, that's fine. So I'm just saying normal SQL statement, and this, because it's grouped by player, it gives me the following results. So I know, for example, if we pick a specific player based on the algorithm, so Van Dyke, for example, we know the algorithm is telling me the algorithm is predicting he will score in the 3rd minute, 4th, and 5th. So this will give you some idea. So we have 30 minutes window here. Either 0, it means the player is not going to score, or 1, which means the player is going to score. And you don't have to have it as, this one. You can have it in real time, so results can come into every minute if you want to provide it. And again, the algorithm itself can be changed. So I just wrote simple algorithm just to show you what is important when you use Hazelcast, which is the simplicity in the development as well as the deployment. Now, just a few slides, and I will finish off. So, as Jakosh mentioned, so we would really love you to try it out. So play around it. Like, if you don't know what you can use it for, or for example, if you have a situation where you're not sure if Hazelcast is the best solution for you or not, stick around after this talk. We'll be happy to answer any question you have and show you what you can do with Hazelcast. Or if you want, you can try this one on the Viridian. So it gives you 2 GB, so it's a free access. You don't need a credit card or anything like this. So you can try it out. And it's important also to give the feedback, but also to look for the context. So we want you to give us the context, what kind of application you want to run on our platform. And as I mentioned, we're trying to reach out and see if you can join our community. I think we have a friendly team. I really like the engineering team at Hazelcast. They are quite active at our various social media and Slack community. So we have Slack channel to answer any questions. So for example, if you go out and try Hazelcast, you got a question, please feel free to share it on our Slack, or we have user group for it. And we also run a live streams. So if you're interested in live coding or you would like to know more, usually we run it on Wednesdays in the afternoon. So we have a Twitch channel, which we're trying to launch. So we would really love to see you there. Maybe you can sign up, or even like if you're interested, for example, to be involved in any way or form, speak to me or anyone at Hazelcast. We have a specific email address if you're interested in, I don't know. We have a specific program if you would like to contribute to Hazelcast. We have a very active community on GitHub as well, because after all, Hazelcast is or was born as open source and still open source. And just to remind you here of your chance of winning $100. So this is a really good, great opportunity. If you scan this code, fill in the form, and if you want to, tag us or use the social media to express your opinion about Hazelcast, do this. We will do the draw afterwards and notify the winner about it. With that, I think I'm done, and I'm happy to take any question about Hazelcast. Thank you.